Hi, welcome to our channel of IGNOU audiobooks. Indira Gandhi National Open University, School of Sciences, SOS, Diploma Postgraduate Diploma Programs. Postgraduate Diploma in Applied Statistics, PGDAST. MST-001 Foundation in Mathematics and Statistics. Block-1 Fundamentals of Mathematics I. Unit-1 Introduction to Sets.
Of Mathematics I. Unit-1 Introduction to Sets. 1.1 Introduction. Sometimes, we deal with some types of collections, e.g. 1. Collection of books in a library of a university. 2. Collection of natural numbers which are factors of say, 80 or any other natural number. Set is also a collection of objects, but it is a well-defined collection. We will learn more about this in Sec 1.2. Consider the collection of states in India. We know that presently there are 28 states in India, and this figure is exactly 28. Neither one less nor one more. Also, if any number of persons, having a general knowledge of states in India, are asked to write the names of the states, then final list of every body will contain the same 28 names. Order in which they write the names of the states does not matter. Such type of a well-defined collection is known as set. In this unit, we will introduce the notations and terminology used for sets. The unit defines set, its various types, discusses hierarchy of sets, Venn diagrams, various operations on sets, and finally the unit is closed by giving an idea of some important and commonly used laws. Concept related to sets is very elementary, and it is used directly or indirectly in the rest of our courses. So, you must understand the concepts discussed in this unit before you proceed further in the course. Objectives. After completing this unit, you should be able to define a set, write a set in different forms, explain the types of sets, draw Venn diagrams, apply the operations on sets, get the idea of supersets and subsets, and get an idea of some important laws related to sets like associative, De Morgan's laws, etc. 1.2 Sets. A well-defined collection of distinct objects is called a set. A set is generally denoted by capital letters such as A, B, C, X, Y, Z, etc. And the objects which belong to the set are known as elements or members of the set and are generally denoted by small letters A, B, C, X, Y, Z, etc. If A is an element of a set A, then we write A, read it as A, belongs to A. If A is not an element of A, then we write A, read as A, does not belong to A. Following example illustrates the term, well-defined collection, or set. Example 1. Consider the following collections and state reasons whether they form set or not. 1. Collection of good cricketers in India. 2. Collection of honest students in a particular university in India. 3. Collection of natural numbers which are less than 5. 4. Collection of rich persons in India. 5. Collection of letters of the word assignment. Solution. 1. This collection does not form a set, because a given player may be good according to some person, but the same player may not be good according to some other person. 2. This collection does not form a set, because a student may be honest according to some person, but the same student may not be honest according to some other person. 3. Yes, this collection forms a set, and elements of this set are 1, 2, 3, 4. 4. Richness is not a well-defined property, because according to someone, a person may be rich while he, she may not be rich in view of some other person. So this collection does not form a set. 5. It is a set, and elements of this set are A, S, I, G, N, M, A, T. Now, you can try the following exercise. Methods of representing a set. A set is generally represented by two methods as given below. 1. Roster method. Dictionary meaning of roster is a list showing persons who perform their duties in turn. As its meaning suggests, in this method each and every element is listed and put, separating by commas, in curly brackets. This method is also known as tabular form or listing method. Remark 1. Throughout the course, we use N, W and Z for the sets of natural numbers, whole numbers, and integers, respectively. 2. Set builder method. In this method, we consider one or more properties that are exclusive to the elements of a set so that no other elements can be the member of the set. This method is also known as property method or rule method. 3 dots are read as, and so on, which means all the elements following this pattern are also included in the set. Prime number, a natural number greater than 1, is called a prime number if and only if it has only two divisors 1 and itself. For example, 2 is a prime number as its only divisors are 1 and the number itself. But 15 is not a prime number because it has 3 and 5 as its factors other than 1 and the number itself. Remark 2. 1. In terminology of set, the symbol used in each part above is read as such that 2. Throughout the course, the sets of rational numbers, irrational numbers and real numbers will be denoted by Q, I and R, respectively. Note, advantage of the second method, i.e. set builder method, lies in the fact that sometimes, or in some situations, we cannot list the elements of the set, or even if we can list them, it may not be practical or feasible to do so. For example, consider the set X. X is a person who born in 2010 in India. Obviously you will be more comfortable with property method in this example. Consider another set X. X is a real number and 1 less than X less than 4. This set cannot be described by listing method because number of elements in this set is uncountable. Thus, above two examples show that in some situations either it is too difficult to describe the set by listing method or it is impossible to describe it. No doubt, there are some examples in which listing method has its advantage. For example, consider the set 28, Bihar, India. It is a set having three elements 28, Bihar and India. Let us now consider some examples to make the ideas of two methods discussed above more clear. 1.3 Types of sets. We have seen that set is a well-defined collection of distinct objects. Also, repetition of elements in a set is not allowed. So once a set is defined, automatically number of elements contained by it has also become fixed. In this section, we shall discuss the different names given to a set on the basis of the number of elements contained by the set. Equivalent and equal sets are also defined in this section. Null set. Consider a collection of those sons having their ages more than their respective fathers. Of course, we will find no such son in this world. This type of collection is nothing but simply known as null set or empty set or void set in the terminology of sets. Let us now formally define null set. A set is said to be null, or empty or void, if it has no element in it. Null set is denoted by or. For example, A equals X. X is a natural number, 1 less than X less than 2, is a null set as there is no natural number between 1 and 2. Singleton set. Consider the collection of mothers of a baby. Obviously a baby has only one mother. This type of collection having a single element is known as singleton set in the terminology of sets. Thus, a singleton set is defined as follow. A set is said to be singleton set if it contains only one element. For example, A equals X. X is an even prime number, is a singleton set as there is only one even prime number, i.e. 2. Finite set. A set is said to be finite set if either it is an empty set or it has a finite number of elements. Cardinal number of a finite set. The number of elements in a finite set, say A, is called its cardinality and is denoted by n, A. For example, 1, if A equals X, Y, Z, then n, A, equals 3, i.e. cardinality of A is 3. 2, if B equals 14, 2, 3, 9, 15, then n, B, equals 5, i.e. cardinality of B is 5. Infinite set. A set is said to be infinite if it is not finite. For example, A equals 1, 4, 9, 16, 25, 36, is an infinite set. Remark 3. Infinite sets are either countable or uncountable. We shall discuss it in Sec. 2.6 of Unit 2 of this block. Equivalent sets. Two finite sets A and B, say, are said to be equivalent if number of elements in both the sets are equal in numbers, i.e. n, A, equals n, B, and we denote it by a tilde B, read as A is equivalent to B. For example, if A equals A, B, C, D, and B equals 2, 3, 5, 7, then A tilde B, N, A, equals N, B, equals 4. Equal sets. Two sets A and B are said to be equal if every element of A is in B and every element of B is in A and is written as A equals B. For example, if A equals A, B, C, D, and B equals C, B, D, A, then A equals B as order of elements does not matter. If two sets A and B are not equal, then we write a B. 1.4 Hierarchy of sets. For given any two real numbers A and B, you know that either A equals B or A less than B or A greater than B. This section will focus on how this type of association is set up in case of sets. Actually, here, we consider the sets contained in some other sets and define them with their appropriate designations. Subset. Suppose A be the set of all working ladies and B be the set of all ladies, then obviously all working ladies are ladies first. That is, all the members of the set A are members of the set B. If it is so, then in the terminology of the sets, A is known as subset of B. Now, let us formally define the term subset. Let A and B be two sets. Then A is said to be subset of B, or B is superset of A, if every element of A belongs to B and is denoted by A B. AB, read as A is contained in B, or A is a subset of B. If we write it as BA, then we read it as B contains A and we call B is a superset of A. Proper subset. Let A and B be two sets. Then A is said to be proper subset of B if all the elements of A are in B and B has at least one element other than elements of A and is denoted by A B. Power set. Let us first consider some examples. I. If A equals, then is only subset of A. That is, there is only one, equals. O. 2. Subset of A. E. If A equals A, then possible subsets of A are A. That is, there are only two, equals. 1. 2. Subsets of A. E. If A equals A, B, then possible subsets of A are A, B, A, B. That is, there are only 4, equals to 2. Subsets of A. IV. If A equals A, B, C, then possible subsets of A are A, B, C, A, B. A, C, B, C, A, B, C. That is, there are only 8, equals 3. 2. Subsets of A. V. Similarly, if A has n elements, then total number of subsets of A are n. 2. Now, let us define what we mean by power set of a set. Let A be any set. Then set of all subsets of A is known as power set of A and is denoted by P, A. Universal set. In IGNOU there are 21 schools such as School of Humanities, SO, School of Social Sciences, SOSS, School of Sciences, SOS, etc. SOS IGNOU Dairy. 2011. If U is the set of all faculties of IGNOU and 1, 2, 3, A, 21, A are sets representing the faculties of 21 schools, then, of course, faculties of all these 21 schools are faculties of IGNOU. That is, all the members of these 21 schools are present in the set U. Here U plays the role of universal set for the sets 1, 2, 3, A, 21, A. Now, let us formally define the universal set. A set U is said to be universal set if all the sets under study are subsets of U. 1.5 Venn diagrams. As we know that examples play an important role to understand the concepts of theory, definitions. Similarly, a diagram speaks more than the words that we may use, and they also make the ideas simple and easy to understand even for a fresh reader. Euler, 1707 to 1783, a Swiss mathematician, was the first who took the step to represent the sets diagrammatically. Then John Venn, 1834 to 1923, a British mathematician, moving a step ahead, simplifying the ideas and made it more user-friendly. That is why diagrammatical representation of sets is also known as Venn-Euler diagram. But usually they are known as Venn diagrams. In Venn diagrams, sets are represented by enclosed areas in a plane as described below. 1.6 Set operations. In school days, a child first learns counting numbers and then she learns how operations of addition, subtraction, multiplication and division are used on two numbers. A similar type of approach is being used here. In sections 1.2 and 1.3 of this unit, you have become familiar with the definition and types of sets, respectively. In this section, we will learn about some commonly used operations on sets. Union. Let A be a set containing the persons getting salary, in hours, between 10,000 and 100,000 per month, and another set B containing the persons getting salary, in hours, between 5,000 and 20,000 per month. For this example, if we are interested in finding those persons who are getting the salary within the range 10,000, 1,000 or 5,000, 2,000, then such persons will be those having salary between 5,000 and 100,000. The set of such persons is nothing but the union of two sets. A and B. Intersection. Let us again consider the example given above. For this example, if we are interested in finding those persons who are getting the salary within the common range, then such persons will be those having salary between 10,000 and 20,000. The set of such persons is nothing but the intersection of two sets A and B. Complement of a set. Suppose we have set of persons of a locality having voting right. Then set of those persons of the locality who do not have voting right is its complement, if the set of all persons of that locality is considered as a universal set. 1.8 Summary. Let us now summarize what we have covered in this unit. 1. Definition of a set with examples. 2. Two methods of writing a set. 3. Definition of various types of sets including empty set, singleton set, finite set, infinite set, equivalent sets, and equal sets. 4. Definition of subsets, proper subset, superset, universal set, power set. 5. Introduction of Venn diagrams. 6. Various operations on sets. 7. Idempotent, identity, commutative, associative, distributive and the Morgan's laws. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter. Look at the screen for table content.